Hello, today we're about to evaluate the value of pi using Monte Carlo technique or stochastic method. Imagine the quarter of an ellipse shown in this diagram. The area of this ellipse is not known, but its value or its law that governing the area of an ellipse is known, which is pi AB. Quarter ellipse will have an area of quarter A equals quarter pi AB. We want to know pi because pi is the unknown for us. Therefore, what's the ratio between the area of this ellipse and the area of this rectangle? The area of the rectangle is well known to be AB. Therefore, to find the area of this ellipse, we'll have to find ratio between area of the ellipse and area of the rectangle. All of this multiplied by the rectangle area, which is AB. To find this will give the area of quarter ellipse, which equals to quarter pi AB. Okay, then how to get the ratio between ellipse area or quarter ellipse area and the rectangle? Measure number of darts thrown randomly to this diagram. Let's see, dart for here, 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 here. Some of the darts are for here. All of the darts are randomly falling on this diagram. Then the number of darts falling in this area, which is quarter of an ellipse, over number of darts falling in the whole rectangle equals the ratio between the area of this quarter ellipse and the rectangle. Therefore, you can make the ratio equals number of darts in the ellipse divided by total number of darts. How do I simulate or mathematically say the dart? Dart is some sort of arrow thrown to this diagram. How could I say it mathematically? The dart is simulated mathematically using the random number. Therefore, I have random number thrown in the x direction and in y direction. Therefore, in this problem, I'll need two random numbers. Random number 1 for random points in the x direction, and also random number 2 for random points in the y direction. Then I have to use those random number to make an algorithm to calculate the pi. Okay, then let's introduce a variable called xi. Such case, we're in the stage of making the algorithm to calculate the pi. let's introduce a variable called xi. Xi equals the random number from 0 to 1, random number 1, multiplied by a minus 0 to give random points in x direction. Okay, then we need to have random number, another random number for the yi. Random number 2 multiplied by b minus 0, random point in y direction. The next stage is to compare between the yi and the xi. Here we have those at xi, they will be corresponding to yi. Let's say this is xi. The yi may be here or maybe here. It's randomly chosen, and this xi is randomly chosen. If it's here, then we'll count it to find the count of number of dots or the number of random numbers fallen in this area. If it's here, it will not be counted. Therefore, I need to compare with this curve. This curve is governed by the equation of the ellipse, which is y equal b square root 1 minus x squared over a squared. Therefore, I need to make f of xi to compare with. F of xi equals, we said, b 1 minus xi squared over a squared. Points on the ellipse curve corresponding to random points xi. Therefore, do I number of histories xi equals random number 1 multiplied by a minus 0, f of xi equals b multiplied by 1 minus xi squared over a squared, yi equals random number 2 multiplied by b minus 0. If yi smaller than or equal f of xi, then it's in the ellipse area, then count equals count plus 1, and if, and then I have to have 2. Now I have to find the ratio we were asking for. For ratio will equal count over number of histories taken. Then our area will be ratio area of ellipse equals ratio multiplied by a times b, which is the area of the rectangle, and the area of ellipse will be quarter pi ab equals ratio times a times b, can cancel b and a with a, therefore pi will equal 4 multiplied by the ratio. And this is how you count, you find the when you evaluate pi using Monte Carlo technique. Let's find here, what if I've used less number of iterations? In such case, this number of points will be less. In such case, my accuracy will be less. Therefore, as long as I increase my number of histories, my accuracy will be higher. Because like that, let's say I took only 5 numbers or something like that. 5. Here the ratio is 100%. Here it's all different. As long as I increase my number of histories, I'll converge to the real value of pi. Thank you very much.